Right, so yet another AI talk, and I'm quite lucky that I wasn't scheduled to talk after Chris' presentation, otherwise it would be a disaster. So I'm going to talk about AI. Wow. I will talk about our experience with Agentic coding on real-world project that we recently had at Mantel Group. Briefly about myself, my name is Illia Kavaliou. I'm a principal consultant at Mantel. I'm also a co-organizer of AWS Brisbane serverless meetup, not necessarily AWS. I spend quite a lot of time working in cloud and digital application modernization, and I'm also an AWS community builder in AI engineering stream. All right, so today I'm going to cover a few things. I will start with the challenge, the problem that we were facing. I will then continue into a bit of evolution of AI engineering toolkit, quite a subjective opinion on where it is now. And I will jump into solutions. So it will be filled with a lot of practical examples, how we tackled some difficult problems using Agentic coding and Bedrock. And finally, I will share some of my thoughts on the impact and some organizational considerations. So the challenge, we were approached by a large major marketing and advertising company that asked Mantel to help build an integration solution. So a fairly simple application that's supposed to integrate with internal services and external services. In terms of tech stack, it was using AWS serverless backend, Lambdas written in Go, exposed via API gateway. We had SQS, we had EventBridge, S3, DynamoDB, a fairly standard stack. The front-end application was supposed to be created using a framework called Svelte. I'm not sure if many of you are aware of that. The infrastructure, the requirement was to deploy everything using infrastructure as code, AWS CDK, hope many of you know what it is. And we also were supposed to use fully automated build and release pipelines using GitHub Actions. However, the challenge wasn't technical. We had a perfect storm of different constraints, and number one was aggressive timeline. We were only given 4 weeks, and that's probably why a client decided to engage a consultancy firm, because they realized that they cannot achieve what they needed to achieve before deadlines set by the industry. The resourcing, we didn't have many people. The core team was only 2 experienced engineers, one in cloud and AWS, and another one in digital. And because we only had 2 people, obviously we had some knowledge gaps. So I'm quite experienced with AWS, with full stack development, but I never had experience with Go. Similarly, another consultant had a lot of experience with React and Angular, but had 0 experience with Svelte. So what can go wrong? And then we also had quite a strict technical requirements, mainly because the client is an ASX-listed company. So obviously they had a lot of requirements on security. We needed to follow some engineering and architectural standards. 2 years ago, I would probably say that it is impossible. Like, we cannot deliver such a project in 4 weeks' time from onboarding until deployment. But we had quite a positive experience using Agentic coding at Mantel, so we decided to take on that challenge. And we only had 2 conditions that we put in front of the client. We want to be able to use Agentic coding tools, and we wanted to use AWS Bedrock as our LLM provider. But before I just dive into implementation detail, I want to explain what is Agentic coding, because myself, and I think a few of you probably met me before, I was quite skeptical about AI. Not as skeptical as Chris, but still quite skeptical. I always thought that it's not just ready yet for software development. And I think before 2020, that was the case when we had classical AI. So in here, I'm talking about software engineering adoption. I'm not talking about AI in general. AI has been there for decades. But classical AI, that's where we had role-based systems with a bit of ML. That's been used for code quality checks and security vulnerabilities. In 2020, when GPT-3 was released and we got all this hype around generative AI, all of a sudden we realized, well, it can actually hold a conversation, it can produce some content, and that means that it can produce some code. So that's why we started using it for code completion and some code generation. Around 2 years ago, a few tools came up, like GitHub Copilot, Cursor. I think a few of you probably used it in the past. And that was the time when we started seeing AI integrated in our development environments. So you didn't need to switch to the tab and ask ChatGPT, copy your code into ChatGPT and anything like that. You could just use your favorite tool. It could be VS Code, you could use another IDE, and ask to give an explanation of the code or help to write some code. I think starting from last year, we started seeing an emergence of agents and agentic AI. And the biggest difference between code assistance and agentic AI, that agentic AI is a system that can actually follow multi-step execution to achieve the goal. So it's not addressing only one task, it can be aware of the context, and the AI can help you to generate multiple steps to follow the implementation until it is completed. And I think where it's heading right now, and obviously no one really knows, but I think the idea that the next logical step will be to have distributed agents that could be self-correcting, aware of the context. They can potentially analyze and generate requirements from your Jira tickets or something like that and come up with the solution of high quality, not what they have right now. And in our solution, we decided to use Klein and Amazon Bedrock with Claude family of LLM languages by Anthropic. For those who are not familiar with Klein, Klein is an open source project. You can just Google and get there. It's an open source project that has ability to integrate with existing IDEs, so you don't need to install a new application. It comes with the very useful feature that it allows you to use any API and any LLM. So you're not stuck with OpenAI or Anthropic models. You can actually connect and use different models for different tasks. So you can connect to Amazon Bedrock, and that's what we did by API. It also comes with the shell integration and browser integration. So it's not just writing the code. It can execute shell commands, the terminal commands. It can also browse your file directories and read files and open up the browser and do some investigation using the browser. And it also comes with the MCP tool support. Amazon Bedrock, I think as many of you know, that's a fully managed service from AWS. It is serverless, and basically it follows pay-as-you-go model. It can scale up and scale down. You don't need to pay upfront for expensive subscriptions. It's got access to a bunch of different models. The ones that we used was Claude. At that time, it was 3.7. Now I'm using Claude Sonnet 4. It also comes with two really beneficial features. One of them is prompt caching. So it allows you to prompt cache a bit of conversation, so it doesn't need to send the massive prompt every time you interact with an agent. But also it comes with cross-region inference, which allows you to connect to the agent in other regions seamlessly if your region experiences some sort of peak demand. And probably 6 months ago, my thought about AI was, okay, all that matters is your prompt. So how about we just come up with a really good prompt, very detailed prompt, let's say to spin up an infrastructure, and say create X lambdas, create DynamoDB, create some integrations between them, and see magic happen, right? Because that's what they promise. Like you look at the demos and you're like, that's the way to go. Fairly soon I realized it was wrong. So it's pretty good. I mean, don't take me wrong, it's still pretty good for your personal projects. It might come up with some very quick and dirty prototype, but it's not anywhere near enterprise-grade production system. For many reasons, but I think number one reason, and that's something that you heard in previous talks as well, it doesn't know anything about your business. It only knows about whatever it was trained for, the information from the internet, very generic. It's going to make a lot of assumptions irrelevant to your business. It's also probably going to use very strange naming conventions, and it will come up with a few services that don't really make any functional purpose for your particular business. It is unaware of your organizational technology standards, and I think that's something that Michael was talking about, the technical steering rules. So it doesn't know whether you have any engineering patterns. It doesn't know if you have architectural standards or principles in your organization. It's probably going to use a lot of outdated packages because it was trained on data available, let's say, 3 years ago. And when I was using it, actually it produced a lot of CDK code that was referring some deprecated methods, because that's all LLM knows about the CDK. And also it doesn't really know your current solution. Even though those agents can scan your directory, read a few files, it's still very likely that they're going to miss some important functionality. They will end up creating code duplications. They will end up creating maybe new functionality that you have already. And because it doesn't know so much, it will try to pull as much information as possible. It will fill up the context window, and that's a working memory for LLM. And the LLM will suddenly get dumb. Like, performance will go downwards really quickly. And I think, and that was me, and I think that's why a lot of people are very skeptical about AI right now when it comes to software engineering. And we hear those claims that actually it takes longer to fix AI-generated code than to write it on your own, that it is too expensive, that AI tools are just simply not ready. Or you're getting some results that you didn't expect. Right, so our solution. We tried a few different approaches at Mantel. We ended up with a few that really worked for us. And number one was that you need to take a lot more time to lay foundations, right? LLMs, they don't know anything about the task they're going to work on. They don't even know whether they're software engineers or they're pretending to be a persona of cloud engineer or a breach inspector, right? So you need to take time to lay foundations. Even in our project, we had only 4 weeks, and I think for the first week, we didn't write a single line of code. We just focused on laying foundations for the AI agent. That was a bit of risk, but when I'm talking about that, I'm thinking about a few aspects. Number one, generic rules. You need to teach AI and LLM how do you want LLM to think about your problem. That's where you can come up with analysis framework with a few maybe output formats, so they're more or less consistent. Your diagram specifications can go there and everything else. Do a bit of research and read LLM-specific engineering prompt instructions, as well as best practices for your particular agentic tool. On the screen, you can see something that I just came up. So this documentation, this steering documentation, gets quite big. It could be like a few hundred lines of text. And that's where we've been using Claude, and Claude actually understands XML a bit better than other forms of file formats. That's the instructions where I'm basically telling LLM, please do not make any assumptions. If you don't know anything, if you're not clear about requirements, assess your confidence level. If you're not confident enough, get back to me and ask questions. You know how agents, LLM is trying to be quite pleasing? So you can suggest any kind of nonsense, and they will be like, oh, great advice, thank you. So we're trying to avoid that. Second, analyze the technical environment. You have engineering standards, you have architecture principles, you have some internal libraries. Like if you're using CDK, it's very likely that your company has already some CDK constructs that have been well tested. You need to feed it into LLM. You need to provide some context so it is aware that if I'm using CDK, for example, first I need to look at the internal package. And only if constructs do not exist there, then I move back and trying to create something on my own. You can use Confluence, Jira, various knowledge bases. AWS knowledge base could be one example if you want to keep it centralized. Repositories, code is a good documentation itself. README files, even meeting transcripts. And you can ask LLM to generate that documentation for you based on the inputs provided. So if you have internal packages and you have access to the repository, and obviously LLM doesn't know about that package because it's internal, or it's not supposed to know about it, then you can ask LLM to generate quite a comprehensive documentation, like you can see on the screen here. I just using like Power Tools, Python, public repo because I didn't want to overshare here. But that's where you can say, okay, analyze this, generate a document where you list all public interfaces, all public methods that LLM can understand and reuse. I do it for all internal packages, and that becomes my role for an LLM. The way how you structure workspace roles, don't put everything into one file, because if you provide too many roles, then LLM gets confused. It's not as smart as many people think. It's got very limited working memory. And you can use maybe a roles folder in your directory where you can structure roles specific to your framework, to the project. There is a concept of memory bank, if you heard about it. I did try to use it. I didn't quite find it very beneficial, but you can test it out. And that's an example of what we used. I probably would structure them a little bit different now, but that's where we had some roles related to CDK only, some roles related to Go, some roles related to API development versus front-end development, some roles for infrastructure. And that's where in Klein, you can use a little toggle within VS Code, saying that when you're working on a particular task, you can toggle which roles will be applicable to that task. So when you're working on infrastructure deployment, you don't need to tell AI anything about your front-end requirements. And because it's an agent that has plan and act modes, I do recommend to spend a lot of time planning. So my approach that you need to analyze the current implementation first. Then in a separate task, you define requirements. In a separate task, you create implementation checklist with step-by-step instructions. And that's all happening in the plan mode. You don't really need to generate and modify any files other than those markdown files. And then only finally you execute the plan. You need to use temporary working files for that. If you try to elaborate a task and create a plan and execute all in one go, then your context window will blow up. So you can use workflows, something that was introduced recently, and I think Hero is actually have it built in, where you can follow those steps one after another as a workflow. And there are some examples, and you've seen something similar already today. On the left, you can see the analysis of the current architecture produced by Claude. And on the right, you see that implementation checklist, which is a very detailed view, and that's what kind of replaces your code review. So think about yourself sitting next to the junior developer and you just explaining step by step what needs to be done. And instead of waiting for like a few days, you just wait for a few minutes and then you're getting some outcomes. But it's really good to have that very detailed step-by-step instructions that have been reviewed so you don't get any surprises. And that's probably the difference from like traditional vibe coding when you just write a prompt and wait for magic to happen. Trust me, it will never happen. Not yet, maybe. And that's another example where in Klein you can see plan and act modes. Plan is basically a conversational mode. It's not going to modify any files, it's just a conversation. And that's where you can see I asked a client to create an S3 bucket and some Lambdas integration without much detail. And client got back to me saying, okay, my current confidence is 4 out of 10. I translated like, I don't understand at all what you're trying to do. And then you can see that it started asking me questions how to reach 9, 10 confidence level. And sometimes it's quite a long conversation where you start questioning yourself. And I changed my mind a few times during that conversation. When I do that, instead of saying, actually, I changed my mind, I use checkpoints. So after each API call, you can get a checkpoint, and then you can restore your conversation back to the checkpoint. I found it extremely useful. And monitor your context window usage. I think Anthropic Cloud supports up to 200K. That's the number of tokens that you can send to the API. I found it becoming extremely bad once your context window hits 120K. So try to keep it small, because otherwise LLM start suffering from what is called, I think the term is something like AI amnesia. So it doesn't quite understand. it doesn't remember some information provided. It doesn't quite understand where we were heading, and the results are getting ridiculously bad. Also in Klein, you can follow the cost of your task, which is quite handy as well. Finally, you can use MCP tools. I'm not sure how many of you know about MCP. So MCP is a model context protocol. It allows LLM to go beyond what LLM is capable to do and integrate with other services. Some of the examples could be that you can use an MCP server to access up-to-date package documentation. So I did mention about CDK, and that LLM probably knows about CDK, everything that was valid 2 years ago. So that's the way to overcome that. So you can use an MCP server to pull the latest documentation of some public packages. But you can do a lot more than that. You can access the database, you can access Postgres, run some queries. You can do web search, web automation using MCP tools. You can also integrate with things like Atlassian products, Git, AWS, so you can create your branches, create pull requests, etc. All right, so the outcome, well, it was a success. Otherwise, I wouldn't be standing here. Or maybe I would, but then it would be a different topic, and maybe I would present together with Chris and how bad it was. But actually, it wasn't so bad. Like, we did deliver. We did deliver to production. The client was happy. We were happy as well. We got a really good case study. We did spend, overall, we spent 50% on foundation. And that's something that you typically don't do on your projects, because human brain, no matter how bad it is compared to LLM, you still actually have a lot more context in your brain than any LLM can have for your specific task. So with LLM, you need to actually start from scratch pretty much every new task. And that's why you need to spend a lot of time in foundations explaining very basic things and making sure that you document them as rules. You probably spend 80% of time focusing on planning and that conversation about what we're going to implement, what is going to be our implementation checklist. We also realized that code reviews took significantly more time than we usually do them during our traditional software development. The reason for that, yes, it does accelerate the amount of code you produce because you can tackle more features and deliver more functionality. But then instead of getting one pull request a day, you might end up getting like 3-4 pull requests a day, and that becomes your job. So it's not a side activity anymore. It is your job to do pull requests. It can be automated using some other AI tools for code reviews, like PR Agent, but I'm not going to talk about this today. Overall, we didn't get like 10 times, 100 times performance boost. We also didn't get that like 20% less productive figure. I think we ended up with probably 2 times performance boost, accounting for some overtime that we had to invest compared to my original estimate. And AWS Bedrock cost was actually pretty low. A lot of people complain that it is expensive. We ended up spending less than $8 per day per developer. Over the course of 4 weeks, it was around $300, which is very reasonable price for the amount of work we produced. And I want to thank prompt caching feature for that. Otherwise, it wouldn't happen. I think we would end up spending more than $1,000. So please use prompt caching. Otherwise, it is still quite expensive. And I do have a few considerations around other aspects. So first of all, it is impacting the entire delivery lifecycle. If you only accelerate in coding, you will see soon enough that you don't have enough requirements for agent coding. You need to spend a lot more time elaborating your tasks. And that's not what you typically do in your 2-week sprint, when sometimes you have maybe 1 hour, 2 hours allocated for elaboration. You need to spend a lot more because you need to provide more detailed requirements. That means that if you only focus on coding, it will shift bottleneck to somewhere else. Either business analysts, product owners, testers, one of them will become your next problem. So it needs to be used across your software delivery lifecycle, meaning that all roles are going to be transformed to some capacity. So don't think about how to use it for code acceleration. Start thinking about how you're going to use it for design and product roadmaps. So a few just takeaways as a wrap-up. Focus on foundations before you see any visible progress. I know that sometimes we become quite impatient, but you need to be patient. You need to set the foundations right, otherwise you're not going to like AI. Centralize and maintain agent rules. Ideally, you should have some champions within your organization, or maybe center of excellence, so that can centralize some of those rules so you don't need to repeat them for every single project. Monitor context window size, otherwise LLM gets really bad. Plan most of your time and execute only at the end. You can even use cheaper models to execute. You can plan using like Sonnet or even Opus, and then you execute using DeepSeek or something like that. You can integrate other services, like integrate Git, integrate Confluence, using MCP tools, but just be cautious because I don't think they have any security or vulnerability checks. So if you're giving your personal access token to your organizational GitHub, it could be a bit risky. Use prompt caching to cut your costs significantly. And finally, once you start using Agentic efficiently, you will see that the bottlenecks are shifting somewhere else, and you need to work with the business how to resolve them. That's everything I wanted to share today. Thank you very much. It's been my pleasure.